Good morning, everybody. Welcome and thank you for joining us. I am Tim Cook from BIOPAC, and I'm your moderator today. Generally, of course, Brenda's doing this, but she's actually gallivanting around Italy on vacation with her family, so we wish her the best, and I'll do my best to take her place today. So give me a little bit of grace as I do this for the first time. Today's webinar is going to be focusing on the new lab streaming layer license that is available within AcqKnowledge as an add-on to AcqKnowledge. We'll actually be highlighting a couple of new hardware devices as well, basically to demo how the lab streaming layer works. One is the cognition system, the Axon-R, and one is the Apex system through TMSI, which is a 24 or 32 channel EEG system. So the webinar isn't focused on those, but we do have a full webinar on cognition already, and we will be doing an upcoming webinar highlighting the Apex system in a little bit more detail as well. But again, those two devices will be used in this webinar to demo the lab streaming layer utility. So during the webinar, again, as I mentioned, if you do have questions, you can submit them through the control panel, through the chat box. And again, as I mentioned, we'll also do some Q&A at the end. Before we get on to our presenters, I do want to let everybody know that we are going to be holding our biannual 4T meeting, and registration is now open through the website. It's going to be held at the UCSB campus, so University of California in Santa Barbara, which is just a couple miles from our headquarters, on July 14 through 16 of 2025. So feel free to look up information on that, and we'd love to have you join us. There's some pictures from last year's conference. And again, it's not only related to everything BIOPAC, but all of our partner companies, the different resellers that we work with are there, our distributors. So it's a nice crowd and a really good time to learn and to mingle with everybody. Now on to our presenters. Mickey Rowe and Fraser Finley are joining us today. Mickey Rowe earned his PhD in neuroscience at the University of Pennsylvania, and after postdoc work, he worked as a research associate in the Neuroscience Research Institute and then joined BIOPAC in 2009. Welcome, Mickey. Fraser Finley, of course, is our CEO of BIOPAC and has over 25 years of experience in the life sciences with physiology monitoring and obviously the physiology monitoring industry. He is a well-regarded expert and presents workshops within the US and all over the world with our other partner companies and distributors. Welcome, Fraser.
Morning, Tim. Welcome, everyone.
I will hand the screen over to you, Fraser. Make you the presenter, and you are good to go.
Thank you. Perfect. Okay, well, welcome everyone. As Tim's already mentioned, this webinar is on our integration of lab streaming layer into AcqKnowledge software. But before we start, I've got a little bit of background information about BIOPAC. BIOPAC develops high-quality scientific tools that allow you to measure physiology anytime, anywhere, with any subject. We've been in business for over 30 years, and 99% of the top 100 universities worldwide use BIOPAC products. And many of the largest companies in the world use our products for development and validation. BIOPAC has now generated over 53,000, or I should say our customers, our users have generated over 53,000 citations. And the BIOPAC Student Lab system is the premier choice for undergraduate teaching labs. All right, so let's get down to business and take a look at lab streaming layer. So BIOPAC is introducing lab streaming layer as a new licensed feature for AcqKnowledge To start with, this is being introduced to enable access of data from third-party devices, and in particular, as Tim mentioned during his introduction, the Apex EEG system and the Cognition Axon-R augmented reality brain-computer interface headset. And between Mickey and I will be giving you some demonstrations and a little bit of background information about that. I'm going to switch displays quickly. Move this across. All right, so many of you will be familiar with AcqKnowledge, and as far as the lab streaming layer integration is concerned, nothing really changes. There's different ways in which the integration can take place, and we'll show you three examples to give you a better idea of how you can utilize this functionality. But this data I'm showing on the screen, this was recorded a couple of days ago. Actually, Mickey was the subject, and this is just EEG data coming from the Apex system. And these two channels are showing the filtered alpha wave activity. So this is C0 and CZ from the headset. And then I asked Mickey to close his eyes. You can see there's an event mark being added in there. And then you can see this beautiful alpha wave activity as he's opening, closing his eyes. So this kind of gives you an idea. For those of you that are not that familiar with AcqKnowledge, it operates Windows and Mac. I'm running on a Windows machine. We've got different menus along the top for different devices, hardware devices, and media, which I'll get into. I'll use that for the demo, so you can actually video as well. But this gives you a quick overview of what to expect when we get into the demos. But let's talk a little bit more about the theoretical part of LSL. So LSL, Lab Streaming Layer, is an open source framework that allows users to combine data from other devices. So think about purchasing two different systems, and you want to try and bring data from both devices into one application so that it's organized and synchronized. You can view it, you can analyze it, analyze them simultaneously. LSL allows you to do those things. And when we're talking about data coming from another device, if we use the language of LSL, we talk about data streams. So if you hear Mickey and I talking about a stream of data, you can basically consider that the data that's coming from another device. But that data stream can come in different formats and at different speeds. So for something like EEG and the Apex system, you may have the analog channels coming in as one stream, event marks coming in as another, and maybe even impedance data coming in as a third. And obviously each device will have its own idiosyncrasies dependent upon how the developer set it up. But the idea is through AcqKnowledge you can access the different streams, and then you can display it and then combine it with other physiological signals or with other devices that are part of the BIOPAC AcqKnowledge ecosystem. So LSL can be used in isolation without being embedded into an application with a user interface. And Mickey will give an example of that. Or it can be a combination of both. And we're showing you the Apex headset. That's a full integration with AcqKnowledge, where there's a combination of user interface as well as the LSL data streams coming in. And I think through the demonstrations, what I just talked about there will become a little bit more apparent made a little bit easier. Okay, so as I already mentioned, the whole concept behind LSL is to simplify the integration of different data streams and different devices. Now, AcqKnowledge does this very well. We already have lots of different hardware devices that can be integrated with AcqKnowledge so that you can do true multimodal recording. So that could be in the form of an eye tracker, an EEG system, and these devices are not necessarily manufactured by BIOPAC. These devices are third-party developed. A lot of work goes into providing that integration, and a lot of the times the manufacturer will have their own bespoke API or SDK that our software developers will use to bring that data in. Well, LSL attempts to simplify that with a more standardized API that people have access to. And as I mentioned earlier, it is an open source framework. And the whole purpose is you end up with this seamless communication between hardware devices and software applications. And then probably one of the most fundamental parts of this is the ability to time synchronize the different streams of data so that when you're performing any analysis or you're looking at the data after the fact, you can be sure that everything is aligned. So in terms of the data that can be shared, obviously the third-party device has to support LSL, and the AcqKnowledge software, in our case, requires a license. So once you've got a device that utilizes LSL and you've got a license for AcqKnowledge, in theory, you can bring the data streams in. Initially, when we release this, we will be allowing you to bring data in to AcqKnowledge. We won't be offering a bidirectional integration. And by bidirectional, I mean you won't be able to access data from BIOPAC hardware as outgoing data streams. We'll be able to bring data in, but not necessarily sending it out. But as LSL evolves in the AcqKnowledge software, those features will become available. LSL has, if you want to learn more about it, has a really nice website that gives a ton of additional information. Gives you the different types of devices that can be integrated, and there are a lot. And it's, for the most part, it's pretty well documented. So if you're a developer type programmer, there's a lot of useful information there that will allow you to access the data and bring it into your own application. If you really want to access data from a BIOPAC device that is recording data in AcqKnowledge, although LSL initially won't allow you to do this, we do have a feature called network data transfer. NDT will allow you to take the data from AcqKnowledge and basically allow you to access that data across the network. So it's not LSL, it's network data transfer, but you can access the data. And that's not just the raw data, that can be any calculation channel that you may have set up. A good example of that would be if you consider the slide or the screen I showed you earlier where I had EEG alpha wave activity displayed. Those are calculated channels. That data is also available from NDT. So you get the raw EEG from the device, from the amplifiers, plus any additional calculations. And all of that becomes available as an outbound stream that you can access and bring into your own application. So that kind of gives you the theoretical groundwork for LSL. I'm going to hand back over to Tim for our first poll, and then we'll get into some demonstrations.
Perfect. Thank you, Fraser. Sure. And the first poll is, are you currently using LSL? If you could all chime in and let us know where you're at with the LSL functionality. That's pretty good, actually. I was thinking it'd be a little bit less, but about 45% are currently hands-on with LSL. We'll give that just a couple more seconds. People are still voting or answering. So yeah, that's good. About almost 45% are currently employing LSL in some capacity. So that's good. We'll end that and go back now for Mickey is going to jump in and provide an additional example. So I will make you presenter, Mickey. And you should be good to go.
Sorry, Fraser and I are in the same office. We've got a feedback loop going on here. Are we good?
That seems to be okay now.
We're good now? Okay.
Yep.
All right. Thank you, everybody, for being patient. Like Tim, I'm kind of new at this. Not a normal thing for me, but okay. I want to talk a little bit about our implementation of LSL. As Fraser said, there are situations where we're going to have an interface which is controlling the device, and there are other situations where you're just going to be relying on some completely independent of us software which is going to be producing the stream. If you're familiar with our software, you know that at the top menu, as Fraser mentioned, there's a hardware choice. So I'm connected to one of our devices, an MP160. And LSL streams are treated as hardware. So if you want to connect to an LSL stream, you would go to the hardware menu, add new device, connect new hardware, you choose LSL. And to give a little bit more terminology, Fraser mentioned that we talk about streams, but we also want to think in terms of outlet streams and inlet streams. So what AcqKnowledge does is it creates inlet streams to match outlet streams that are already existing. So right now I've essentially asked AcqKnowledge to look for outlet streams, and specifically outlet streams which have regular sample rates. We're not finding any because we don't have any in the network. And for those of you who are not as familiar with LSL, that's a really important point, that you can only acquire data from streams that are coming from computers that are on the same network as the computer that will be running AcqKnowledge. Okay, so just as a general test, during development, we wrote a little application that creates an outlet stream and just pushes sine waves through it. So I'm going to run that program. All right, so this created the outlet streams. It's got 8 channels of data. And so now if I refresh, I should see it. Okay, so that's this outlet stream that I've just created called Simple Stream. All right, so now I have this new hardware connected. With AcqKnowledge, every graph window that you have open is should be connected to hardware. This graph window that you see in front of you now is already connected to an MP160, so I can't use that graph window. I need to create a new one, so you can use Control N or just File New. And you see when you have multiple hardware devices connected, when you create a new graph window, it asks you what you want, what hardware device you want to connect to it. So I'm going to choose Simple Stream for my new window. Okay. Right. Okay. So again, so now, as I mentioned across the top, you have the hardware choice. With the hardware choice, when you're connected to an LSL stream, is going to be the name of the outlet stream. If you are familiar with our software, it will treat the hardware just like any other kind of device. That so, as I think I mentioned already, this stream has 8 channels in it. You can choose to acquire all of them or not. We'll just go ahead and acquire all of these. So when I press start, it's just going to begin acquiring these 8 sine waves. So as I mentioned, as soon as I started that application, it started pushing data out. So AcqKnowledge, when I press the start button, it basically starts grabbing the data that are pushed into the stream from the moment I hit the start button. So you're not getting all the data that are in that stream, you're just getting the data that were pushed after I hit start. And with this current setup in this graph window, I can start and stop. So you can see also how the discontinuities here, that the places where I stopped were not acquiring that data. So again, it's not complete. It's just acquiring the data that are acquired, that are being pushed into the stream while you're acquiring. Okay. An important thing to try to understand if you're going to be using this feature is that there is a difference between the LSL streams and other hardware types. If I go out back to the application, so I close that window, so now I've destroyed the outlet stream, so that outlet stream doesn't exist anymore. If I create it again, so just restart that application, it's a different stream. So if I go back to this window, you kind of think that, oh, you're already connected to that stream, but you're not. It's because I've destroyed the original outlet and created a new one. We actually have to go back and reconnect to it. So you can first disconnect from the one that was there and then reconnect to LSL again. So the simple stream is there again. And see now, because I lost that connection, I don't know if I can just, oh yeah, okay. So this probably will work. Yes. All right, so I was able to convert this window from one that wasn't attached to any hardware back to the window connected to this new simple stream. All right, so the next thing I want to talk a little bit about is combining data. So I want to get rid of all of this. All right, so I previously set up my MP160. See, I just, there's an analog output and I have that fed back into one of the analog channels. So I'm also creating another sine wave with the MP160. That will show up in this window. Okay, but I'm going to use a feature of AcqKnowledge called linked acquisition. And if I select both of these windows, there are some other options that you have. This is going to merge the 2 sets of data into one graph window at the end. I do want to talk a little bit about the synchronization. Well, okay, let me do this first. Okay, so I press the start and now I'm acquiring data in both windows. Right, so I just clicked one start button and it started listening to the LSL stream and started the MP160 telling it to acquire that data. So just one button gets everything rolling. And then if I stop them, they also stop together. And since I asked it to merge, okay, I don't care about this. I'm just going to give it my standard name for one. Delete me. Okay, so I'll get rid of this file later. All right, so now this graph window has the MP160 sine wave and all the sine waves that were from LSL. When I started to say before about the synchronization, if you really need tight synchronization, if you're doing like evoked potentials or something like that, where you need millisecond precision across trials with a stimulus presentation system or across separate data acquisition systems, you really should use some kind of hardware signal that's common to the stimulus presentation software or the two data acquisition systems, because that's really the by far the best way of getting very precise alignment. Using just these features in AcqKnowledge, you can get close, but close would be probably tens of milliseconds off. All right, I think done with this. So I want to move on to just another example, because we want to look at hardware. That's what we want to use is LSL for, not just creating sine waves out of the computer. Okay, so I have the Cognition headset now set up to produce some streams. We're going to try to record from one of them. So like before, I have to attach to the new LSL device. I'm going to choose this raw device attitude because it gives an interesting visual. You can see as I move the headset, how that affects the data. And I need to create a new window attached to that stream. Okay, and I'm going to turn off the plotting of some of these channels, which are less interesting, because I just want to look at the ones that show the pitch, yaw, and roll. Okay. All right, good. And show the video so you can see. All right, so as I pitch up and down, you see how the pitch axis is the one in the middle. Principal roll should be the top one. That's this. It's hard to control just one of the axes at a time. Yaw is at the bottom. Okay, so you can see this is successfully acquiring data from one of the streams from the Cognition headset.
Okay, so before we dive into the live demonstration, I'm going to give you a little bit of information about the Apex EEG headset. So this is a nice little portable device. It's 24 or 32 channels. What we're going to be showing you today is the 32 channel version. Comes with, well, it has options for different EEG caps. The one we're using is a gel-based cap. Mickey is going to be wearing that. One of the nice things about it, you can communicate with the computer via USB, so you have a good old-fashioned cable connection. You can also communicate via Bluetooth. Comes with its own Bluetooth dongle, USB type A that you plug in to your computer, and then the device will communicate wirelessly. So if you need a little bit of flexibility within lab or within a relatively enclosed space, a home or workplace, then the Bluetooth works quite nicely, because you've got one cable coming from the head cap down to the device. You've got a strap that this can be worn around the waist, or as a shoulder type situation. There's an SD card within the device as well that will also convert the system over to a logger. So the moment you're using Bluetooth, all the data is being logged onto the onboard memory. But if you go outside of the range of Bluetooth, the system will just continue to operate, collect all of the data. Now, obviously, you won't be able to view that real time, which is the advantage of the Bluetooth. So the person can be approximately 10 meters line of sight between the device and the computer, and real time, you'll see the EEG waveforms coming across. When it's in logging mode, you obviously lose that ability. But the beauty is you've got these sort of three modes of operation. You've got tethered USB, you've got Bluetooth, line of sight, real-time access and viewing of the data, and then you've got a logger as well. So it's pretty convenient. It's reasonably straightforward. On board the device as well, for anyone that is logging, this little flag here, this is an event mark. So your participant can mark events while they're using the device. And obviously within AcqKnowledge, you've got event marks anyway. So if you're in an in-lab situation and you want to mark things such as eyes open, eyes closed, you can do all of that within AcqKnowledge anyway. But this is kind of a nice tool for those remote situations where the device is being used as a data logger. Okay, so that kind of gives you a little bit of information about the setup. Tim, I'm going to ask you to switch over to my other computer, and I'll get everything set up there so that we can collect some data from that machine. Turn this camera off.
Okay, you should be good to go.
Awesome, thank you, Tim. And bingo. All right, so cool. What I'm showing you here is AcqKnowledge connected to the Apex headset. I've already got my channels and everything set up. The way this works, this is a more sophisticated integration than what we've got going on with the sine wave example that Mickey started out with. This has a full user interface, so you've got all the 32 channels that by default they're enabled, but I've turned these off because I don't want to record from 32 channels. Mickey is going to be my participant, and hopefully, if I set this up correctly here, there's Mickey back on screen. He honestly volunteered to put the cap on. There was no pressure applied. What I'm going to quickly do is put some gel on the cap, and hopefully we'll get some data from the system. So what I'm doing at the moment, this is O1 and OZ. And I'll use FZ as a reference.
And you know it's working because you can feel it tingling.
All right, so according to Mickey, you can feel the gel on there. We'll see what's going on. I've got this connected to the system via the USB cable. So this is hardwired. Those are from the occipital region, O1, OZ, and then And there's FZ, which is what I'm using for my reference. And I'm going to close that out of the way for the moment. If I hit start, we'll start to see some data coming across the screen. And this is auto-scaling in real time, but there is an option on here. If we come down, we can look at the impedance monitor and we'll get a view of what this is like, and we can see our impedances are not great. So I'm just going to come over and see if I can get these a little better. Napkin. Hopefully those will come down a little bit. We obviously just put the gel on. Probably not going to get the best view of this, but I'm going to hide these two channels. The bottom two here that we're looking at, these are filtered, and if I zoom in a little bit, get a better look, not quite that much. Go. Perfect. Nikki, if you can just close your eyes for me. And open your eyes. Bear with me. And then let's just close your eyes again, please. Okay, now open your eyes. Awesome. Okay, so all right, so our impedance levels are not the best, but we are still able to get some alpha wave data out of there. What I wanted to do is show you how this connection works. Here we go. So I mentioned earlier this is connected via USB. So if I turn the camera around, Nikki, if I can ask you to hold that up in front of the camera, perfect. So the black cable that you're seeing coming out of the top of the headset, that is the USB cable. Now down below, you can see the white connector. That's connected to the headset. And then you've got an array of LEDs along the top just over here, indicating battery life and that there is a connection to the system. The cap that Mickey is wearing, as I said earlier, is a gel-based, it's a 32-channel cap. This here, what is called the controller, this has to be connected immediately before you can start to collect data. And this is what's passing the streams of data from the Apex headset. BIOPAC is then bringing those data streams in so that we can view what's going on. Now, just as Mickey showed earlier, you can do things, you can combine with other devices. So if I move this across, I've got an MP160 that I've got connected here. So we've got two devices, which is going to be quite typical because maybe you would like to collect data such as respiration, ECG, temperature, other such signals. Those can be collected using an MP160 system. And then just as Mickey showed earlier, you can use the linked acquisition. So set up linked acquisitions. We've got two devices, the Apex and the MP160, and then you can start them simultaneously. Just asking me to change the recording mode. Now these two devices are recording. On the right, we've got the alpha wave data. On the left, we've got the information from the MP160. And then we can stop our acquisition, and just as it did before, it's going to create one unique graph with those files and combined the files from the the data from the MP160 with the data from the Apex headset. And then these are channels that are just turned off. I'm only viewing 3 channels. And again, if we zoom in, get a better view of what's going on over here, you can see you've got the raw EEG, or sorry, the alpha filtered EEG 2 channels, plus 1 channel of the MP160. And you can view these simultaneously. The other thing that I was doing during that acquisition, the camera that you're looking at, so this camera over here, this is the media feature within AcqKnowledge. So any of you that are using AcqKnowledge, I always recommend using, this is just a simple webcam that I've got set up. This allows us to get that behavioral data, which is great to kind of better understand what the data, if there's artifacts or things that we're a little bit unsure of. The video is synchronized with the physiological data. And then when you come back in playback mode, you can then literally frame by frame look to see what the data was doing at that point. So this is a super helpful feature. It works when you're using linked acquisition. In terms of limitations with the number of devices, last week I was running 5 MP160 systems from a single computer. And there are some super nice features when you do this. If you're running the same setup on all 5 devices, you can push all the settings to all 5 MP160s simultaneously. And then when you use the linked acquisition to start, it starts all of them and then stops them all, and then it merges all of that data straight into AcqKnowledge as well. So that kind of gives you a look-see of the level of integration that we've got with the lab streaming layer. I want to thank Mickey for assisting me here. He makes a much better subject at this point. I'm just out of curiosity, I'm going to take a quick look at the impedance just to see if that's come down any. And it has. We've got greens on all of those. So it just takes a little moment for that gel to penetrate. You know, so what we've been going a few minutes now. What I'll do is start recording again, and we can just take another quick look. Let's zoom in, and what I'm going to do is follow the same protocol. Give this a second. Bingo. Okay, Mickey, if you can just close your eyes for me, please. And then open your eyes. That's awesome. Okay, so for those of you a little bit unfamiliar, all I'm doing is pushing in some event marks here. You can see the number 1 just there. You can see when Mickey closed his eyes, you can see that increase in alpha wave activity. The second marker over here, I asked him to open his eyes, and you can see that alpha wave being suppressed the moment he's opening his eyes. It was a pretty compelling demo. We were able to set that up quite quickly. The impedance levels dropped down nicely after a couple of minutes. So that gives you a pretty good overview of the LSL. Unfortunately, we couldn't get a connection to the headset. I'm sure there's something blatantly obvious that in the heat of battle we're missing. These things happen. That's the fun of doing a live demo. Tim, if you can move me back over to my other machine, if you don't mind, please.
Sure.
Thank you.
Okay.
Just coming up. Awesome. Thank you. Perfect. Thanks, Tim. So that sort of concludes the demonstrations we have today. We're right around the top of the hour. Tim, I'm not sure if there are questions that we can take. We've got a couple of minutes left.
There's honestly not that I'm seeing. If anybody does have one right now, but feel free to add it into the chat box. We'll give you a minute or two.
It's because we did such an awesome job, Tim. We preempted all the questions. If anyone has questions that they think of afterwards, you can always email us through support@biopac.com, and we'll be able to provide you with more information. But it sounds like we're pretty much done, and we're at the top of the hour, Tim.
Yeah. The only one that came in kind of towards the beginning was, would the third-party integration occur in pseudo real-time or in post-processing? And obviously, it's not even pseudo real-time; it is in real-time.
Exactly. Yeah. I think was a pretty good demo there with the EEG and the sine waves. They both worked well.
Yep.
Cool.
Well,
All
again,
right.
this was recorded, so we will get it posted. You'll get a link to it, so you can rewatch the parts that need to if you've got additional questions. And again, always feel free to reach out to our support team or your local representative for additional support on this if you need it. So thank you again to everybody for joining us.
Yeah, thank you, everyone. Thanks, Mickey, for being an excellent subject and for participating today. Appreciate it. Nice job, Tim, as well.
Thank you. Yeah, hopefully Brenda's enjoying Italy.
Yeah, okay. Thanks, everyone.
Bye-bye.